What if a visitor from another star system just entered our solar system? Imagine something so ancient and foreign that it has traveled across the galaxy for millions, maybe billions of years, only to briefly cross paths with us. That's exactly what happened when astronomers discovered 3I/Atlas, an interstellar comet unlike anything we had ever seen before, a true alien traveler passing through our solar system. The rarity of such a discovery cannot be overstated. Before Atlas, only 2 interstellar visitors had ever been confirmed: Oumuamua in 2017 and 2I/Borisov in 2019. Then, in 2020, came 3I/Atlas, the third. That means that in the entire history of astronomy, we've only ever seen 3 objects like this. It's almost like watching a once-in-a-lifetime event. In fact, you could live your entire life and never see another confirmed interstellar comet. That's why these objects are interesting. The story of its discovery is equally exciting. In April 2020, astronomers using the Atlas Survey telescope at Haleakala Observatory in Hawaii first spotted it. At first, it seemed like a normal comet, but soon the data told a different story. Its path through space didn't match anything that would make sense if it were native to our solar system. Scientists realized with awe that it was moving far too fast to be bound by the sun's gravity. The shock was immediate. This wasn't one of ours. It was a visitor from the stars. That's when astronomers looked more closely at its interstellar passport. Every comet carries one, hidden in its orbit. For 3I/Atlas, the signature was unmistakable. Its trajectory was hyperbolic, meaning it wasn't looping around the sun like normal comets do. Instead, it was flying past, on a one-way trip, never to return. According to calculations published by the Minor Planet Center, its speed exceeded 30 miles per second, far greater than what solar system comets typically achieve. This made it clear 3I/Atlas was a true interstellar traveler. When astronomers catch sight of a strange object hurtling through our solar system, the imagination doesn't just stir, it ignites. Could these celestial wanderers be more than just rocks and ice? Could they be messengers from another civilization? This isn't a new question. Back in 2017, the discovery of Oumuamua, the first known interstellar object, sent shockwaves through the scientific community. It didn't behave like anything we'd seen before. Its bizarre acceleration and elongated cigar-like shape led respected scientists like Harvard's Avi Loeb to wonder, was this an alien probe, silently slipping past Earth? Now, with the arrival of 3I/Atlas, another interstellar visitor, the mystery deepens. Though it shows no signs of artificial origin, its mere presence reminds us the universe is vast, and our understanding is still so limited. Each new object from beyond the stars challenges what we think we know, and dares us to imagine what might be out there. Think about what 3I/Atlas represents. This comet has wandered interstellar space since long before humanity even existed. According to NASA, interstellar comets can take millions or even billions of years to travel between stars. It may have formed around a star that has long since died, leaving 3I/Atlas as a messenger from a past that we can no longer see. In that sense, it's not just a comet, it's a time capsule carrying secrets from a distant, vanished world. What if it also carried the raw ingredients of life? Scientists know that comets in our own solar system contain organic molecules, the chemical building blocks that may have helped life get started on Earth. If 3I/Atlas carried similar molecules, it supports the idea of panspermia, the theory that life's ingredients can move between stars, hitching rides on comets. Imagine the chemistry of alien worlds preserved inside a fragment of ice and dust, drifting silently through the galaxy and briefly passing by our sun. And why the name 3I/Atlas? It's simple. The 3I means it was the third confirmed interstellar object, after Oumuamua and Borisov. Atlas comes from the survey telescope that first spotted it, a name that quietly marks its place in history as part of a tiny but growing family of known interstellar travelers. The comet is an icy wanderer, estimated to be up to 20 kilometers in diameter. NASA's Hubble Space Telescope has captured its teardrop-shaped coma of dust, streaming from a solid, icy nucleus. Meanwhile, the James Webb Space Telescope has detected molecular carbon dioxide and water ice within its coma, showing that this interstellar visitor carries volatile compounds similar to those found in comets from our own solar system. As of early July 2025, 3I/Atlas was about 416 million miles from the Sun, racing along a hyperbolic trajectory at roughly 37.3 miles per second. It is expected to make its closest approach around October 30th, 2025, passing just inside Mars's orbit. Because its path is hyperbolic, it will not stay. 3I/Atlas is destined to continue its journey out of the solar system, never to return. But here's the mystery. Where did it come from? Unlike 2I/Borisov, whose path suggested it came from the direction of Cassiopeia, 3I/Atlas's origins remain unclear. The problem is that over millions of years, gravitational tugs from countless stars and even giant molecular clouds scramble an object's path. According to research published in the Astrophysical Journal, tracing its exact birthplace is nearly impossible. It might have once orbited a star we can no longer identify, or even one that no longer exists. That unknown makes its journey even more mysterious. That's the bigger picture. Every interstellar object is a fragment of a puzzle we're only beginning to assemble. Each one could reshape our understanding of how solar systems evolve and what ingredients are common, or rare, throughout the galaxy. The discoveries of Oumuamua, Borisov, and Atlas in just a few short years suggest that with better tools, we might soon find many more. And those tools are coming. NASA's upcoming Vera C. Rubin Observatory in Chile is expected to revolutionize our ability to detect faint, fast-moving objects. ESA's Comet Interceptor mission, launching later this decade, aims to wait in space until the next suitable comet is found, potentially even an interstellar one, so we can study it up close for the very first time. Imagine the thrill of directly sampling material from another star system. If you enjoyed the journey, don't forget to like the video, share your thoughts in the comments, and subscribe so you never miss what's next.